Let's now take the case of 50 knots of headwind outbound. As before, our safe endurance is 10 hours and our true airspeed is 300 knots. Our outbound ground speed, O, will therefore be 250 knots. When we turn round and come home, the headwind becomes a tailwind, making H, the homebound ground speed, 350 knots. Here's the basic equation again. T equals EH over O plus H. E is 10 hours and H is 350 knots. And O is 250 knots. 10 times 350 over 600 is 5.833 recurring hours, or, more sensibly, 5 hours and 50 minutes. 250 knots for 5 hours 50 comes to 1458 nautical miles. The effect of a headwind has been to reduce the distance to the point of safe return. What about 50 knots tailwind? As before, our safe endurance is 10 hours and our true airspeed is 300 knots. With 50 knots tailwind, our outbound ground speed, O, will be 350 knots. When we turn round and come home, the tailwind becomes a headwind, making H, the homebound ground speed, 250 knots. Back to the basic equation. T equals EH over O plus H. E is 10 hours and H is 250 knots. And O is 350 knots. You do the calculation this time. Don't click onto the next scene until you've got a result for both T and for the distance to the point of safe return. You should have come up with the answers 4.166 recurring, or 4 hours and 10 minutes, and 1458 nautical miles. So we have shown that the maximum range is always the still air case. Whether the component is head or tail, the effect of wind is always to reduce the distance to the point of safe return. If you increase speed on the outbound leg, you reduce it on the inbound leg and vice versa. However, you always lose more by slowing down than you gain by speeding up by the same amount. Let's summarize this lesson. The maximum range that we can fly outbound and still return within our safe fuel reserves is called the point of safe return. It is dependent on fuel and is not affected by the distance between the departure and destination airports. It can be called point of safe return, point of no return, PSR or PNR. The basic equation to find the time to the PSR is T equals EH over O plus H. Having found the time, the equation to find the distance is distance to the PSR is O times T. Despite the similarity of the formula used, it is a completely different case from point of equal time or critical point. The maximum range is always the still air case. Whether the component is head or tail, the effect of wind is always to reduce the distance to the point of safe return.